and respected members of the nations. Thank you for having us here today. We're gathered on the traditional, ancestral, and unceded territory of the Musqueam people on whose land this facility operates. My name is Genio Pugliese. I'm from CZRO Bio, and we build nation-owned infrastructure that generates revenue while restoring land and water. This is a fully deployable platform designed for Indigenous communities to own, operate, and scale. Today, I'll show you how it works, how it generates revenue, and how we're deploying it now. We're actively seeking 3 to 5 nation partners for near-term projects in 2026. Many nations are balancing 2 priorities: protecting land and building long-term economic independence. Most projects force a trade-off between the 2. Either developing the land for revenue or protecting the land for future generations. What's missing is infrastructure that does both. This model generates revenue while improving land, water, and food systems. And the nations that move early will shape how this gets deployed. This is the platform, a regenerative eco-park built on nation land. It converts CO2, water, and nutrients into multiple high-value outputs. This is not a single product facility. It's revenue-generating infrastructure designed to scale and replicate, and it's owned and operated by the nation. The model is simple. We convert CO2 and water into 3 revenue streams. Now, majority of the people that grow this microalgae, they have some issues. It's very difficult to replicate, to grow at scale, and it gets contaminated quite easily. What we found, our singularity, is that we were able to build it in such a way that our algae can scale and grow 500 times more efficient than our closest competitor. And our algae that you'll see, if we'd invite you to our facility that's in Langley, you will see that the algae that we have there has been there since 2022. We bought the algae from the University of Waterloo and filled one of our tubes. Over 300 tubes there in Langley. Each one of them are growing microalgae 365 days of the year. And we're able to harvest 240 of those days. It's very scalable, and it's bringing microalgae into a convenient and price that's affordable. Multiple outputs from one footprint, and that's what drives the economics. Now, the revenue comes from these 3 streams. First, BioEnhancer. This is the primary driver with recurring demand. Second, biomass products for agriculture and feed. Third, carbon-linked value streams. This structure creates strong margins and diversified revenue from a single facility. So right here, we separate the algae by using a proprietary technology into the green stuff, which is called biomass. And this is about 3% of the liquid in there. The biomass was traditionally used for biofuel. And this, was a waste product, 97%. What we noticed is where the BioEnhancer was being placed, vegetation was growing. So there's an agricultural input in here that's breakthrough technology. So what we found was this BioEnhancer awakened the biology of the soil. It actually worked with the microbes that are naturally in there. In a teaspoon of soil, there's over 600 million microorganisms. They're all responsible for a different part. They're vital. When I was young in the late 70s, early 80s, there was no organic aisle. All fruits and vegetables were organic because the soil was still good. But over time, that's changed. And what we can do is revert back to the way soil was. This product can do that. This structure creates strong margins and diversified revenue from a single facility. The other thing that I'd like to point out too is when we are growing the microalgae, it's taking in 2 inputs. One of them is CO2. Now, when you're looking at this, imagine an acre of these tubes. It would give you the same CO2 impact as 5,000 acres of trees that have been growing for 25 years in terms of CO2 consumption. In addition to that, the water that we use does not have to be clean drinking water. When I was presenting this to the Lower Nicola Indian Band, and in particular, a good friend of mine, she was standing by a body of water, and we were talking about doing the microalgae in that location. It requires a lot of water. And what she told me was this. She said, look, this area is subject to drought. We can't afford to use a lot of water on certain things. And I said, what about this water? And we were standing by a body of water like Nicola Lake. It was full of algae bloom. And she said, I'll pay you to take that water. And that's the type of water our technology can recycle. So we're taking two waste products, CO2 emissions from a factory, a plant, a data center, and then also taking wastewater and repurposing it to grow microalgae, arguably one of the most important crops of our lifetimes. It produces the most oxygen on this planet. Now, this is the primary product, as I said, the BioEnhancer. It's a proven agricultural input with repeat demand. Field trials through the University of Simon Fraser and the University of the Fraser Valley proved several things. One of them, improving yields, stronger soil, improved nitrogen fixing bacteria, and reduced fertilizer use. It activates the biology already in the soil. This is not theoretical. This product is already in use, and that's what anchors the revenue model. Rather than explain it further, I want to show you how this performs in real world conditions. This is the actual product being used by growers today and how it's sold in the market.
BioEnhancer isn't a chemical fertilizer. It's a living biological signal that wakes up the microbes already in your soil. It boosts nitrogen fixation, improves nutrient uptake, and strengthens roots. That means healthier plants with fewer inputs. For farmers, that translates to real savings, lower fertilizer costs, higher yields, and better quality crops that bring in more at market. Field studies with Simon Fraser University and the University of the Fraser Valley showed up to 30% greater nitrogen availability and stronger early plant growth. Across dozens of on-farm trials, growers are reporting faster germination, deeper roots, and higher crop weights, often with 20 to 40% less fertilizer. Each drop of BioEnhancer starts in our mega-cell algae farm.
So this product is produced continuously 240 days of the year and sold into agricultural markets. Now let's look at what that means at a commercial scale. And what I'm suggesting is an infrastructure model for one of your nations here. I said this is a 200-ton regenerative eco park operating as a regional hub. It produces over 9,600 tons of that BioEnhancer annually, which again, as I mentioned, is the primary revenue driver. It also utilizes approximately 3,000 tons of CO2. The biomass that's produced is a secondary output for fuel or feed applications. The facility itself, as Chief Louis mentioned the other day, creates 15 to 20 long-term operational roles on site. But beyond that, it supports additional employment across packaging, distribution, and regional sales. So the impact extends beyond the facility itself into a broader local economic ecosystem. This model delivers economic output, employment, and regional scalability. This is probably one of the most important parts. The nation owns the land, the facility, and the operations. The nation retains the majority of revenue and long-term control. Our role at CZRO Bio is to provide the technology, support, training, and optimization. We participate through production-based revenue sharing. This is nation-owned infrastructure with aligned partnership. Now, last year at NABOC, we saw projects like wind farms generating around $20 million annually. What we're introducing is a different model, a single 1-acre facility is designed to generate approximately 18 to 20 million in annual revenue at full production, with significantly less land and faster deployment. It can also be deployed on non-arable land while supporting agricultural productivity through its outputs. But the real difference is how it scales. This model expands incrementally, acre by acre, based on demand. So instead of committing thousands of acres up front, nations can start with one facility and grow capacity over time. That creates a more flexible and controlled path to scale. Now, deployment follows a 4-phase approach: feasibility, construction, initial operations, and expansion. Each step is structured to reduce risk and ensure stable deployment. This gives nations a clear and controlled path to ownership and operation. We also have already done the research on the different financing packages available and grants that are available, and our team will help you with all of them. Execution matters. We've spent approximately 9 years developing this system and over $14 million in R&D money that was actually from government grants. Another $5 million of our own money got put into this. Our team brings expertise across algae, engineering, and carbon systems. As I said, we've invested well over 11 million, it's actually 14 million to R&D, and we support projects from design all the way through operation, including training and maintenance and continued support. Any of our market customers that we've found now will become your customers if they're in your area. So nations are partnering with a team that knows how to deliver. We're currently seeking 3 to 5 nation partners for near-term deployment. We're ready to move immediately with aligned partners. Our full-scale facility is in Langley, about 40 minutes from here. We're arranging site tours for nations who want to see the system operating in real conditions. If you're here the next few days, I will take you through this system. We also have a live demo unit here at NABOC along with our team at the booth. Some of you have already seen it. If this aligns with your nation's priorities, we invite you to come, speak with us, see the system, and explore the next steps. Thank you.